All right, recording back, rolling. We're towards the end of class. So you guys have been working on this lab, and you guys have been getting empirical measurements, which is the start outcome, and also calculated speeds. Right, and some of you guys have pretty much the same number all the way down for, but like if this is like 2.1, this is like 2.2 or something like that. They're pretty close all the way. And some of you guys are actually even closer than that, right? All the way down. So let's put together a graph. I said I wanted to do with you guys. Speed is a function of theta. Right, you guys see that speed is a function of theta? Yeah. So let's put that graph together. Now, I saw Felipe, Michael, and Richard had some really good data. And I'm going to do something kind of funny with the graph this time. I'm going to go to Desmos. Desmos. In my algebra class, I have to pull this up all the time. Right, so, yeah, we go. Right, so first I'm going to make a prediction as to the basic shape of this graph. Because if B is my dependent variable and theta is my independent variable and everything else is held constant, like the length and blah, 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 it's all constant. Okay. Guys, can this be like y-axis, x-axis? Right, you guys see that? And in the place of everything else, I can just type any constant, or it could just be 1, like 2GL, could just call it 1, whatever. Okay. And I should model the basic shape of the graph. Right, you guys get that idea? Okay. Actually, you know what? I did that already. So just to save a little time. You guys see I typed right here? I type y equals, and I get square root of 1 minus cosine x, like that. Right. And so, guys, I'm predicting. Hey, guys, everybody up here just for a few minutes. Right. Okay. I'm predicting that if I have speed as a function of angle, it's going to make this graph that maybe if you zoom in real close, at a glance, it might look kind of linear. But if you zoom out, it actually does kind of curve down a little bit. Right? Now, guys, let's interpret this. What's the largest angle that you could practically use today? 90 degrees from the vertical, go up to 90 degrees. Guys, where is 90 degrees on this axis right here? 1 point.
We did more than 90.
Guys, do you think Desmos is thinking in terms of degrees?
Radians.
Radians. So how many radians is equal to 90 degrees? Pi over 2. Is that like 1.57 something? Okay, guys, that would be right here. Is 1.5 something. So the domain of your graph actually only goes from about here to here. Is that? And the way I'm interpreting the rest of this is if you had like maybe like a maybe you took like a garden hose and you like forced it into a loop and you had like a marble that was rolling through. Maybe you could go above that and that would represent this bit. Hey guys. Okay, so this would be I think that's what's gonna happen. So let me open up a new Desmos here. Right. Or I think this is gonna be the basic shape of the graph, but we're gonna find out exactly from empirical data. All right, so you guys right there, Felipe, what were here, I gotta get a table going. Guys, here's how you do Desmos. Type in the word table, T-A-B-L, as soon as I type E, bam, I got a table. Now I can plug in some coordinates. So, Felipe, what were all the different angles you guys used?
40, 50, 90, 30, 20, 60, and 70. Yo, slow down.
A little slower. 40, 50, 90, 20. Okay.
90, yeah.
40, 50, 90, 20.
90, 20, 30.
30.
30. Wait, I think you put, okay, yeah. 60 and 70.
60, 70? Like that? Okay, just roll the angles? Okay. Right. Now, I'm choosing you guys because I saw that your calculated values and your empirical values were extremely close all the way down. So this should be a really nice looking graph. But we're going to see. And so just tell me your empirical values, the numbers that were straight off the speed gate. How'd they go?
1.22.
1.22?
1.71.
1.71?
2.86.
286?
Is that 30 or 20?
20 degrees?
That's 0.73.
0.73?
1.07.
107?
2.15.
215? And
2.39.
239. Okay, so that's all the data. Now, if I zoom out, okay, that's what the data points look like. Okay, so do you guys see how that looks kind of flat? Okay. Now, you guys know that the x-axis, y-axis, that's just in whatever units we measured. Now, I haven't figured out how yet. Maybe somebody can tell me. I don't know. Do you guys know how to like stretch or squash the axes?
Like the gear on the top right.
Oh, yeah? Gear on the top right.
Like try it. Like
this range right here?
Yeah.
This one? Graph settings?
And then type in for x-axis and y-axis, you can change those.
X-axis, like this?
On the greater than, or let's say greater than x.
Oh, right here?
Yeah. And you just type in what you want the boundary to be.
Will it squeeze the whole axis?
Yeah.
Yeah, well, so if I go from like well, actually, I want to change the y-axis, I think. Okay. So if I change this from like 0 to, let's see, well, it goes up to maybe 3. But there. Oh, yeah, yeah. All right, that was a good call. All right, yeah, thank you. I could not figure out how to do that. Yeah, thank you, guys. Here, let me change this to like 5. Yeah. All right. Yeah, that looks pretty good right there. Yeah, 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 yeah. All right. All right. So, does that like it could maybe fit that curve, maybe something like that? All right. And then you can also create a regression line. I think if you okay, guys, if you click this, it'll just create a straight line, but it's not exactly linear. It's actually part of this type relationship, right? So how can you do that? So what you do down here is you type y, then you subscript 1, and then right arrow key. Then you have to hit the tilde. So it'll create a regression for me according to whatever model function I want. And I want that square root weird looking, so this one right here, square root and cosine. So I'm going to do SQRT, gives me square root. Okay. And then I got 1 minus a cosine of the angle. Now my angle is basically x, right? Okay. Now if I type in x, and then I got to do subscript 1. Okay. It creates a graph that doesn't make any sense. Guys, that doesn't look like it does that data at all. Right? So now one thing, guys, again, because X, Desmos is thinking in terms of what unit? Not degrees, but radians. So how can I convert degrees, which is straight off the table? These are all degrees. How can you convert degrees to radians? Pi over 180. Right, is that right? Pi over 180? Right. So I'm going to multiply here. I think if I type the word pi, yeah, it gives me pi over 180. Okay, let's see if this fits better. Okay, that looks better. Guys, looks better. But see how this maxes out at, well, square root of 2? Like that? Because I bet if you do, well, okay. Anyway, I'm going to go back to, mouse cursor, back to the beginning. I'm going to type a times, and then it'll tell me what a is. A is factor of 2.89, right? Now, the number isn't really important. Guys, do you think the length of the string has something to do with that number in front? Yeah. Right. The important thing is the shape of the graph. And look at that. Guys, look at that regression curve. It fits right through those data points. Look at it. So you can make an exact equation out of your data. Ah, you guys see that? Yeah, which is modeled from that parent function right there. Right, you guys see it? Right. All right. All right, so I have a few minutes left. Now, in your table, guys, everybody make sure your name's on your paper. Your name's on your paper, right? Your name? Okay. You guys, hold on to this because next week I want to have you guys construct some pulleys. I'm going to take the last few minutes of class here to play a pulleys video for you guys. Yeah.
Pulley.